Oh, welcome back. I believe that it's not good to conclude the topic on circle without treating some problems in circle. And before I start treating the questions or solving exercises, I think I should do some, you know, reminder, a kind of memory jogger, so that whenever you come into any exam or test to handle circle problem, you will know what to do, how to do it quick. What I just try to let you know is this: circle problem is like playing games with rules, so that once you know the rules, you can quickly make your move. Let's start with this. When you have a circle, the total length of this place, round, is 2 pi r, where r is the radius. The total area of the surface is pi r squared. And then, if we have it cut like a pie, we have, it will subtend angle at the center. Now, the whole angle is 360. So, this length will be proportional to the angle subtended at the center, or the area. So, length of r will be theta over 360 times 2 pi r. Area of sector will be theta over 360 times pi r squared. Now, we can leave that. Oh, before we leave this, I also told you that a sector can be converted to cone. So, assuming I have a sector like this, and I'm converting it to cone, you understand? This place will become the circle under the cone. So, and this radius here will become the slant height here. This radius will become the slant height here. So, this height can be easily gotten to. You understand? If I have theta here as 2, as an r here, so I'll be able to get this place, I'll be able to get the surface area of the slant height, of the slant, of the curved area, sorry. I'll get the area of the curved part of the cone. So, you can see how you can easily move from one place to the other. So, once you know how to move, you will get to solve these problems easily. Here, this one is theta over 360 times 2 pi r. Let me make it L. So once it comes here, it is also equal to, let me make this one, r cube. It's going to be 2 pi r cube, that is for this case. So since that is the case, you can see this one and this one, they have a relationship from this place. So just go through the lectures, you get all these things here. Now, after this, we talk about chords. Now, we talked about chords. Moving from this place to this place. We said something like, if this one should pass through this chord, and if it divides this one into 2, it is perpendicular to it. We also proved that if any line should cut this one perpendicularly with 90 degrees, it must pass through the center. You understand? So, we also talked about 2 chords. If this chord, A, B, and CD, if the distance of this one to the center is the same thing as this, AB is equal to CD. AB is equal to CD. And what does this say about chord? I think. Then we also spoke about tangents and seconds. Chord, tangent, seconds. So we spoke about chord, tangent, seconds. Yeah, like this, this, this. This one is tangent. These are extended chords. It can also be referred as seconds. And let's call this one A, B, I, C, C, D. For this type, we mentioned that AB, AI times BI is equal to CI times GI. Please take notes. For this one, we also know that since AI times BI, now at the same time is equal to, let me make it like this, TI squared. This product of this will give us ti squared. That is one aspect of the sector and tangent. Secant and tangent. Now let's look at when it is intersection of chords. Intersection of chords. So when we have chords like this, let's call this AD, CD, and this is I. Note, this is not the center. If it is center, all these ones will be equal. So we can also say here that AI times BI is equal to CI times DI. So with this, let's look at, yes, the relationship between angles. You know, we talk about chords, and when we have chords like this, it's called the circle into two parts. Segments, segments. So they always talk about segments. Anything inside here, segments. Anything here, segments. But when we are talking about equal segments, something inside the segment, we are talking about from one leg and the other leg to specific points on the circumference or other part of the segment. Now, if I have, let's say this is the diameter. If I have an angle at this circumference like this, let me call this alpha. From this same leg, let me say it's AB. Most times, nobody will draw this for you. But just know, in as much it is extending from the same point, like this place and this place, it is coming out from the same place. You can see. But in the same segments, please take note. Now, let me remove this so that you understand what I mean. Nobody will draw this for you. You will know that it is there. Now, see. It has been proven that all these angles in the same segments, that this one is equal to this, is equal to this, is equal to this. That is one. Since this is a center, all of these angles here, when you check this angle at the center, you're going to have 2 alpha. So this angle here is double of all of this. You understand? Now, assuming from this same leg, we have in the other part of the segments, other segments, you know, this is major segment, this is the minor segment. From this same leg, you have another angle subtended of the circumference here. This one and this one, it has been proven that, let's call this one beta. Alpha plus beta are supplementary. And you also know that if this one, from this same leg down here to this place, it will be beta. From this place to this place, it will be beta. So you just have to calm down and look at it. Anytime I'm going for circle problem, this is the first thing I check. Center, circumference. What is the relationship? Now, since you have been able to get this, let's look at another one. Now, let's look at semicircle. You know, you have said that the angle at the circumference is half the angle at the center. So this place is 180. So it gives this place to be 90 degrees. 90 degrees. Then, I like to mention this, that if you have a tangent here, and you have line from the center to the tangent, the angle between the two of them will be 90 degrees. That's let's talk about alternate segment as well. Now, if we have a chord like this, and we have a tangent like this, you can see that's the tangent, and the tangent goes like this. There is an angle between this piece and this chord. Let's call this A, B, C. So, since this angle here can be called, let's say, theta. This part is alternate segments to this angle here. You can see it is on the other side. It has also been proven that this here is equal to this. So you can see this one and this one are equal. And be like this. You know, same segments. Same segments. So you see. And I also want to remind you something. If you have a circle like this, and from a point, you drew a tangent to the circle. From the same point, we drew another tangent to the circle. This one and this one will be equal because they proceed from the same points that's been broken to. So I think I have tried to like do kind of enough reminder. So you can go back to the lecture and check. It's not too long, and I believe that it covers more than enough for any exam. Now let's solve some real problems now. So the question goes thus. The wheel of a scooter has diameter 140 centimeter. How many revolutions per minute must the wheel make so that the speed of a scooter is kept at 132 kilometers per hour? Now, we know the diameter of scooter to be equal to 140 centimeter. The speed we are given to be 132 kilometers per hour, and that will be equal to 132 kilometers over 60 per minute. And 1 kilometer is equal to 1,000 meters, and 1 meter is also equal to 100 centimeters. So let's convert it to centimeter, and this will be equal to 132 times 100, that is meters times 1,000. So centimeters per minute. Now, for each rotation of this, distance traveled will be equal to 2 times pi times 140 over 2, and that is 140 pi. So that is for one rotation. So how many rotations must it make per minute? Number of rotations to be made per minute will be equal to speed divided by circumference, and that will be 132 times 100 times 1,000 divided by 60 times 140 times pi. So let the calculator come to our head here. So the answer is approximately 500 revolutions per minute. So that's the answer. So for it to keep this speed per hour, it must make 500 revolutions per minute. Now let's do this one. Look at this diagram. We have P, we have Q, we have R. And we have to find P, Q, and R. At the center here, you have 140 degrees. At this place, you have 38 degrees. Most of these things, you solve them using knowledge of triangle. That is all. Okay, let's go. From this place to this place will be 180 minus 140. And go on a straight line. This place. So this place will be 40 degrees. And if you look at this, this is radius, this is radius. So we're having an isosceles triangle here. So R equals to P. This place and this place are equal. And from here, we can say that 40 plus R plus P is equal to 180. Angles in a triangle. Total angles in a triangle. And we know that R equals to P. Therefore, 40 plus 2R is equal to 180 degrees. So 2R is equal to 180 minus 40, which is 140 degrees. So R is 140 degrees over 2, which is 70 degrees. So since P equals to R, so P is also equal to R, which is 70 degrees. So we have found R and P. Now, let us look at some other thing here. We have 38 degrees here, and this place is also radius. So this angle here too will be 38 degrees. 38 degrees. What does that mean? It means that this angle here, that is AOB, this angle AOB, you can easily find it. So here will be 180 minus 38 minus plus 38 degrees, which is 180 degrees minus 76 degrees, which is 104 degrees. So it means that this place is 104 degrees. I might not even have gone to this extent. The angle here will be the sum of these two angles. So this place here is 76 degrees. You can see this place is 76 degrees. Fine. Now, Q here is angle of the base of an isosceles triangle. This one here and this one here are equal because they are all radii. So they are all radii. So this one is equal. So this part here will be equal to this. So we have 2q plus 76 plus 40 is equal to 180 degrees. Please, this angle here is not equal to r. It is just a portion of r. Take note. R covers from this place to this place. So this place is not equal to r. So please take note of that. So, but this portion that is here and this one are equal. That's why I call this one 2q. So 2q plus this 76 plus 140 degrees plus 40 degrees is equal to 180. You know, triangle, angles in triangle. Therefore, 2q is equal to 180 minus, what is 40 plus 76? 116. So Q will be 64 degrees over 2, which is 32 degrees. So I just want you to know, that's why I'm just trying to make it informal, not trying to write everything down. So just know that when you're handling this thing, it's just like a game. Pick it. You will see so many things on angles, on straight line, angles in triangle. And that will make it to solve it. Simple. Let's look at another one of this circle theorem. Now look at this. We have a diagram, circle, with some shapes inside. And we are told that PQ is diameter and SR is parallel to PQ. We should calculate A, B, C, D, and E. From this, if this is the diameter, we are so sure that the angle at the end of a semicircle in a semicircle is 90 degrees. So D is equal to 90 degrees. Simple. Now, this is parallel to this. PQ is parallel to SR. And by the time you look at it, you see that C and 35, they are alternate angles. So C is equal to 35 degrees. Alternate angles. So we have gotten this. 35, 90. So with this, we can easily calculate E. That is, angles in triangle PQR must be equal to 180 degrees. Therefore, 35 plus 90 plus E must be equal to 180 degrees. So E must be equal to 55 degrees. So we have been able to find CDE. So this one is 55. Now don't forget, opposite angles of cyclic quadrilateral are supplementary. That is, A and 55 are equal to 180 degrees. So A plus 55 degrees is equal to 180 degrees. That is, A plus E are equal to 180 degrees. So A will be equal to 125 degrees. That one is done. So this is 125. Now, in triangle PSR, all the angles too must be equal to 180 degrees. Therefore, B plus 125 degrees plus 35 degrees must be equal to 180 degrees. So B must be equal to 180 minus 160 degrees, which should be equal to 20 degrees. So you can see, it's just a flow. It's a flow. Sometimes you need to create some angles for yourself to find, so that you'll be able to find some other ones. It's just a flow. Follow the rules, you always get the answer. Now look at this. We have a circle, and we have a diameter. At the end here, angle PTQ, we are told that PTQ is 22 degrees. Angle ROT is 98 degrees. You can see how it is formed. We are now asked to calculate angle QSR, this one. You have to calculate that one. Now, let's see how we can go about it. I've always told you. Quickly check the relationship between any angle at the center and at the circumference. So from this place, I can see that this one is at the circumference. And I have this one at the center. So if I can get this one, I can get this. Now, we have, from this triangle, look at triangle QOT. This place and this place will be equal. So, which means that this place will give us 22 degrees. because it's an isosceles triangle. So let us find angle QOT. Angle QOT will be equal to 180 degrees minus 22 plus 22 degrees. 180 degrees minus 44 degrees. That's 136 degrees. Now, with this, we can calculate angle QOR. So, angle QOR will be equal to angle QOT minus angle ROT. That is, this full angle minus this one will give us this case. And that is going to be 136 degrees minus 98 degrees. And that's 38 degrees. So, you can see this place now is 38 degrees. And from here, look at this. This is angle at the circumference. This is angle at the center. Angle QSR is equal to angle QOR over 2. Angle at the circumference. So just the ability to identify the angle. Assuming you can't identify it fast, you can do something like this. Draw another one here. And from there, you can see that this one and this one will be equal because they are in the same segments. So you can do it. Just make sure you practice enough and you'll be getting it just like this. And from here now, I can see that I have gotten this one to be 38 degrees. This one now will be equal to 38 over 2. That's 19 degrees. So you can see, very easy, straightforward, and you get your answer. Several conditions might come up. I cannot work everything. But in case you have any challenge, contact me, and I'm promising you to help you out. Look at this. A circle of radius 3 cm is drawn, described in a right angle triangle ABC. Right angle at C. If AC is 10 cm, find the value of CD. Now we know one thing. This is the center, and we are told that this is 3 cm. And this place too will be 3 cm. You understand? That one stands true. And we know from our theorem that when two tangents generate from the same place, they are equal in length. So this place, this place is 3 cm. This place too will be 3 cm. From this place to this place is 10 minus 3. You know, this is 3. So the remaining part will be 10 minus 3, which is 7 cm. So let's work it like this. So this will be 7 cm here. So I have it like this. 10 cm. From here to here too will be 7 cm. So let me call this place T. So I have 7 here, 7 here. In the same vein, from this place to this place, let's call it L. From this place to this place too will be L. And it is a right angle triangle. So we can now see that L plus 3 and this place L plus 7. By the time you apply Pythagoras theorem, this one and this one should be able to give us this one. So let's go on. So you can see that BA squared is equal to BC squared plus AC squared. And what is BA? BA is going to be L plus 7. What is BC? L plus 3. What is AC? 10. Now, we have been able to bring out some values. So let's gather the like terms. So I can now see L plus 7 squared minus L plus 3 squared will be equal to 100. And you know this is difference of two squares. So I can now see L plus 7 plus L plus 3 into L plus 7 minus L minus 3 will give me 100. So this is 2L plus 10. 2L plus 10. So this is 4. It's giving me 100. Therefore, I can easily say 2L plus 10 is equal to 100 over 4, which is 25. So 2L will be equal to 25 minus 10, which is 15. So L is 15 over 2, which is 7.5 centimeters. And note, we are asked to find the value of CB, and that is L plus 3, just like we have done here. So CB is is equal to L plus 3, which should be equal to 7.5 plus 3, which is 110.5. So I believe you can see. I have tried to simplify it all, so I expect that you get it. Now look at this. We are told that Pn is 5 centimeter, and PQ, okay, and Pn, yeah, from this place to this place is 12 centimeter. PQ is 4.8 centimeter. We are now to calculate PR and PT. And you know we have discovered that the product of this place and this place is equal to the product of this place and this place. So let's go on. So we can easily do that by saying PR times PQ is equal to PM times PN. And at the same time, since it's generating, the tangent is generating from this same point, it is going to be PT squared. Now, what are the values given? We are asked to find PR. PR, what is PQ? 4.8 is equal to 5 times 12. So PR is equal to 5 times 12 divided by 4.8. So this is 4. 4 in 20 in 50. That is 12.5 centimeter. That is PR. So PR is 12.5 centimeter. Now let's find PT. PT also be equal to PT squared will also be equal to 5 times 12. So PT will be equal to square root of 16. And that is, so that's approximately 7.75 centimeters. Now we are asked, if PNR is equal to 110 degrees, that is this place, 110 degrees, and PNQ is 55 degrees, okay, find MPQ. MPQ. Now, you know, from our theorem, we have realized that this angle here will be equal to 55 degrees, the exterior angle of cyclic quadrilateral. If you look at it, P, R, okay, RP, MN is a cyclic quadrilateral. So that is where you start from. So automatically, this place, this angle is equal to this angle here, 55. And now we have triangle PRN. The total angle in the triangle should be 180 degrees. So let's call this one alpha. So angle RPN is equal to alpha. And the triangle RPN, alpha plus 55 plus 110 should give us 180 degrees. So what does that imply? It means that alpha will be equal to 180 degrees minus 165 degrees, which is equal to 15 degrees. So angle PQM, okay, angle MPQ. Angle MPQ is the same thing as angle RPN, which is 15 degrees. That was solved.